Okay, so let's continue talking about this. Explore creating and solving compound inequalities. So first, how do you read this chart? So for this chart, this is talking about the notation right here is in between. So for a baby, it has to be in between 0 and 1. This includes 0 but does not include 1. Okay? So the way I know that it doesn't include 1 is it doesn't have that bar underneath. So this one has 1 and 2 and everything up to 3 but not including 3. So we could even say 2.5, 2 and 3/4, but it can't include 3. Okay. This one does include 3, 4, but doesn't include 5, and everything in between 3 and 5, but not including 5. Okay, in between 5 and 12, this one includes, but it does not include 12, and so on. So after you learn how to read those, let's answer the questions. Which groups would satisfy being at least 3 and younger than 18? 3 and younger than 18. So which group is between 3 and younger than 18? Would it be the baby? No. Would it be toddler? Come on, guys, wake up. No! So toddler? No. Preschool? Yeah. Grade schooler? Yes. Teenager? Yes. Young adult? No. Because this one's going to be 18 and older from here on out. So all these are no. So your answer would be preschooler, grade school, and teenager. All right, and teenager. Any questions? Okay, next one. Which groups would satisfy being younger than 12 or at least 21? So this would have to be younger than 12. So in between 0 and 12, not including 12, right? And at least 21, or at least 21. So this one, as a Venn diagram, would look like this. You only want the things A or B. Okay. So which one would be at least 21? Well, does it include 21 or no? Okay, so at least it would have to include 21. So this one would be at least 21. So would it be the young adult or adult that includes 21? Adult. So it would be adult. And what's the other? Is toddler between 0 and 12? Yeah, preschooler? Grade schooler? What about baby? Baby was up here, and baby was between 0 and 1. Okay, so it wouldn't include teenager, young adult, or citizen or senior citizen. Okay, check your answers. Make sure you have it written down. So on yours, you can't do this check mark, so you have to actually write down each one. So it would be the baby, toddler. So take some time, write that down. Mm. Yeah, I would put senior citizen also if it said at least 21 or older, or and older. So if it said the and older part, then yeah, I think they just didn't write that down, so they probably do mean the senior citizen. Yeah, I guess you could make the same inference from just at least 21 as the same as and older. So include senior citizen. Good job, Luis. All right, next one. What age ranges would satisfy being younger than or equal to preschooler or older than a senior citizen? So younger than a preschooler, find preschooler. Which one's younger, back or forward, or up or down? Up. Okay. So this one's going to be younger. So all you got to do is find these two. Really, you could even circle this. Instead of just the number, circle that inequality and circle this inequality. Now all you got to do is make it its own. So between 0 and 5, put your x. These ages are younger than preschooler. So it's just like your bookends. So from 0 to 5, not including 5. Okay, now or older than a senior citizen. So what would be older than a senior citizen? I don't think you should say older than a senior citizen. When you're a senior citizen, there's nothing older. Don't worry, there's no senior citizens in here. We can talk about them. They don't care. I'll never hear about it. So what would you say for a senior citizen? Okay, so a senior citizen would be older than 55. Does it include 55? I can't see it. Yeah, so if it includes it, you got to put that bar. So you'd have the 0 less than or equal to x, which is less than 5, or x is greater than or equal to 55. Okay, what age ranges would satisfy being at least a preschooler and grade schooler? So you only want preschooler and grade schooler. So come up to the chart. You need this one and this one, right? So preschooler and grade schooler. So find your bookends. What's the least amount of age? How old can you be to still be a preschooler? What do you think, guys? What's your least amount? 3. Okay, so you're going to circle 3 with the sign. What about grade schooler? What's the oldest for grade schooler? Yeah. Okay, less than 12. Less than 12 doesn't include 12. Just know to circle a sign with it and you'll be fine. So this one includes 3, this one does not include 12. So now put your bookends, so it would be 3, 12, copy down the signs with it, and put your x in between. So in between 3 and 12 would be the ranges for a preschooler and a grade schooler. Any questions? How is this? So the times where you would put and is when they're right next to each other to where there's no gaps in the number line. But if I wanted to talk about something with a toddler and a young adult, you see how there's this gap in between, right? So we can't include that, so I would have to do this one and then or this one. So would I write this one, write or, and then write that one, because there's all these gaps in between. So all this information. If I just put it from 1 to 21, I'm including these three. I don't want to include those three. So when they're not next to each other, that's why we're putting or. When they are next to each other, that's why we're putting and. Exactly.
What is the middle one? It's and.
Yeah. Yeah, so going back to the Venn diagrams, this one would be and this one here would be or. Okay. I think on or you would include the middle though. Yeah. Okay. Okay, from your observations, what is the difference between an and statement versus an or statement? We just answer that. So go ahead and write your answer. Which statement clumps connected groups together? Is that and or or? So you have two choices here, and or for that one. Which statement clumps disconnected groups together? And or. So I talked about all that right now. Go ahead and write it. Test yourself whether you're paying attention. Like, I don't need a test to say if I was paying attention. I know I wasn't paying attention. No? No? Okay. All right. About 2 minutes to write that down. Okay. Ready to share? Okay. What is the difference between an and statement versus an or statement? Karen, you want to answer this one? Oh, you cheated. You used the words from down here. But yeah, that's exactly right. I know. What do I expect? What do I expect? Good job. Okay, so and connects groups or disconnects groups. And if you needed to see a visual, do the Venn diagrams and you would see the parts that they have in common, right? And then this one would be the parts that they do not have in common, would be the or. Okay, which statement clumps connected groups together? Is that and or or? And. Which statement clumps disconnected then? Or. All right. Okay, explain one. So we're going to solve compound inequalities involving and. Solve each compound inequality and graph the solution. So let's do these two together. We have 4 is less than or equal to x plus 2, less than or equal to 8. I'm not going to build one wall. How many walls am I going to build? 2. Okay, go ahead and put your dotted lines to stay organized. Now, what is keeping x from being alone? What number is keeping x from being alone in the middle? 2. So what do I want to move? 2. What operation is going on? And what is the inverse operation? So the operation is? What's the inverse? Subtraction. Good job. So we're going to subtract 2 because we want to move that. But you have to do it to all three sides. What is 4 minus 2? 2. 2 is less than or equal to x, which is less than or equal to, what's 8 minus 2? 6. Now I'm just going to write it again, but to make it look nice because of the wall. And you're all done. If you don't like this way, there's another way, but I think it's harder. Make 2 equations. So solve for this one. And then this is pointing towards the 4, so it still needs to point towards the 4. So you could solve each equation and get the same answer, but it'd be broken up, and then you got to put it back together. Much harder. But you would get the same thing. Put the x. 2 is smaller than 6. Pointing towards the 2. Pointing towards the x. And we would get the same answer. But you got to break it up, put it back together. Jacqueline. You let your teacher know you're here? Okay.
Are they here? Or am I looking at something else?
Oh, okay, part B, let's try that one. So if you're confused on what to do, if I wrote it like this, what would you move first? The 3. So we're going to do the same thing and move the 3 first. So we're going to subtract 3, all 3 sides. What is negative 5 minus 3? Negative 8. Less than or equal to? 2x. Less than?
6.
Okay, no more. You've had enough. You're full. Okay, who's hungry? What do I do now? Okay, I'm going to give you a second and then I'm going to call on someone. Think of what is the operation? What do I want to move? What's the inverse operation? Good job. Divide by 2. You didn't even let me call on anyone. I was looking forward to that. 2 goes into negative 8 how many times? 4. Good. Negative 4. Less than or equal to? X. Less than? 3. Good job. And okay, solve each compound inequality and graph the solutions. Okay, Jonna, what'd you do first on this one? Okay, I'm gonna build the wall real quick for organization. It's not a must, it's like your training wheels just to get ready. Okay, add 3 you said to both sides? Okay, all 3 sides, good job. And what is negative 2 plus 3? 5. Oh, try again. You owe me $2, you have $3. Good job. 1 is less than or 1 is less than what? Nice. X. Less than, what's 5 plus 3? 8. Okay, so 1 is less than x, which is less than 8. I'm going to write it nicely. Was anyone confused on how to do the graphing part? No? Remember I've been showing you how to split it up into 2 different answers? There's you could either split it up or you could just know, hey, this is 1 is less than x, which is less than 8, right? And I put that between here because look, I have 1, 8. Now if the variable's on the left side, I can put it to the left, right? So think of this as an arrow and it goes to the left. But here's the thing. Can I do the same thing here and say 1 is less than x?
No.
Why?
Because of the variable on the right side.
Okay, so if I switch it, it was pointing towards the 1, make it still point towards the 1. Which way does the arrow go? To the right. And I only care about the ones that are overlapping. Good? All right. Okay, let's try this one. Okay, Maricela, how do I do this? Okay, so you're subtracting 2 on all 3. Let's start over here. So you owe me 10, you owe me 2. No? You owe me $10, you owe me $2. Okay. So you owe me 12, less than. 3x plus 2 becomes 3x. Less than or equal to, what's 8 minus 2? 6. Good. Now what? No whispering answers. Who's whispering answers? I heard someone say divide. Like whisper divide. Alright, divide what? Oh. Not 3x. You want to divide by just what you want to move, so we're dividing by the 3. Go ahead. 3 goes into negative 12 how many times? What's the negative divided by a positive? Okay, guys, look at this. So if you cover up the negative and cover up the positive, what's left? Negative. So what's the negative divided by a positive? Negative. All right, less than what? Take your time. Take your time.
Wait, I didn't see where I was at. Wait, I got lost where I was at.
Okay. So what's 3 divided by 3? You told me the answer for that. 1. Good job. What's 1 times x?
1x.
Okay, 1x. But what's another way to write it? Just
1.
No.
I don't know.
You're right there. So I just want you to say 1x and then what? What's 1x equal to? Just. Do I always have to write this? Or I could just write that, right? I don't have to put a times 1. So what is 1 times x?
Wait, I was stuck.
Okay. So Marcella, what is 1 times 8? What is 1 times 10? What is 1 times 100? What is 1 times 20? Okay, ready for the big one? What is 1 times x?
X.
X, there we go. Alright, good job. What is 3 goes into 6 how many times? 2. Okay. Now we got to graph it. Okay, Jonna. The genius. You ready? You're laughing so much. Alright, how do I graph this? What should I circle? Okay, negative 4. And what?
2.
And 2. Okay, for 2, should it go left or right? Left. Negative 4, left or right? Right. Okay, check if you missed anything. Anything else you want to tell me? Okay, ready? Open or closed? Are they both open? Closed? On which one?
4.
This one?
2.
This one? You gotta be sure about your answer, because I'm not sure about telling you. Which one?
2.
2? Why? You know. What's the reason? What does that mean? Okay, Rami, why is this one closed? Because, did you guys hear the answer? Oh, you did hear the answer. Okay, good. So it's equal to, this bar right here is what tells you that it's closed. Since there's no bar, that's why it's open. So it's telling you that 2 is part of your answers. All right. Okay, discussion. Explain why 2 less than or equal to x less than or equal to 6 can be considered the short method for writing the n compound inequality of x greater than or equal to 2 and x is less than or equal to 6. So a few times already today I've solved it both ways. So why is solving it this way the short method, whereas this one's the long one?
You have to split them up and go back
Okay.
together.
So if you start out with this one, you would have to put it back together at the end, most likely. What else? How would you be able to start it? Oh, actually, this one, sorry. I was imagining this one had something like that. So then we could say subtracting it here. Whereas on this one, if it was something like that, where you add 2, you'd have to subtract here, subtract here. So it's a little bit more work because you're doing 2 problems, whereas this one's just written as 1. Okay, make sure you have an answer written on that. We're going to keep moving on. Now we're on to OR problems. So OR is where there's going to be a gap in the middle and they point opposite directions. So there's no overlap on there. So solve each compound inequality and graph the solutions. -4 plus x is greater than 1 or -4 plus x is less than or equal to 3. So I'm going to add 4 here, build a wall, add 4 here. X is greater than 5. What should I do on this one? Karen, what should I do on this one? Here, I'll build the wall first. What should I move? No? What do I want to get alone? Good. So I want to get the x alone, so I want to move the 4. How do I move a -4? Add it. Add 4, add 4. X is less than, what's -3 plus 4? I'm laughing because Marcella is back there going. Just say it. So you can say x is greater than 5 or x is less than 1. So you would not write this as, well, you could write it like this. It just looks funny. So if you wrote it like this, it means the same as over here, but when you graph it, you'll realize that this is the OR statement. So go to 1 and go to 5. So 2, 3, 4, 5, 6, 0. Put at least one number to the right and left. Okay, we're going to circle 5 and we're going to circle 1. Now it's easier if we look at this one, but we could look at this one also. For 1, do I point to the right or left? Are you looking at this one? Okay. For 1. So think of an arrow. Which way does this point? To the right or left? For this, for 1. Imagine this is an arrow. Which way is it pointing?
Oh, left. I'm looking at it on that side.
Okay. There we go. To the left. Good job. You're so sure of yourself. I thought you were going to just start yelling at me.
Sorry.
To the right! Alright, so this one's to the left. Now look at 5. So this is the one you're telling me, Karen. Which way does it go? To the right. Okay. So you're looking at 5 that entire time? No worries. Okay, notice how this one doesn't talk about in between here. Should I have shaded either of these? No. Okay. So I don't shade them because the signs, it doesn't have the equal sign. And it points opposite directions. Now I want you, before we move on, look at this one and look at the end one on the last page. Do you see the difference between the graphs? So or points to the left and right, and just would be the in between. So n looks like this. Okay, let's do the next one. 2x is less than or equal to 6, or 3x is greater than 12. Okay, 2x is less than or equal to 6. How do I move the 2? So build your wall. How do I move the 2? Divide by 2. 2 goes into 6? 3 times. Now notice this is a 3x, that's a 2x. So I can't do this like I did on the other ones.
Can you do both at the same time?
I have to do them separate because they don't have a 2x in common. Everyone see that? So there's no way to put it like this. So 3x. What should I do to get x alone? What is that? That's sign language for divide. Divide by 3. X is greater than 4. When do I flip the sign when I divide? When I'm dividing by a negative. Good job. When I divide by a negative, that's where the sign flips. Build a wall if you need to. All right, let's label it 1, 2, 3, 4, 5, 0. Okay, circle your 3. Open or closed? Closed. Left or right? Left. Okay, Aureliana, let's graph this one. X is greater than 4. So I should go to 4. Circle it, open or closed? Right or left? Genius. Good job. So basically, all real numbers are answers except for 3 to 4, including 3, but not 4. Okay, go ahead to you try. Try those 2 problems. And try the next page as well.